3, 2, 1, and liftoff of Discovery, hoisting harmony to the heavens.
Hello everyone, today we are taking a look at how NASA plans to continue innovating during Artemis. NASA has a large list of thorough reports and documents highlighting everything related to the future Artemis missions. These missions consist of not only returning humans to the surface of the moon, but setting up a more permanent human presence. In addition, there is a detailed plan highlighting important information, such as continuing to innovate, moonwalks, sample acquisition, and more. Specifically, NASA goes more in depth into its Commercial Lunar Payload Services or CLPS initiative, consisting of 14 US companies on contract for future Artemis missions. In addition, there are many future Artemis missions past the first, meant to provide great value for humans on the surface, and the agency as a whole. All of which is vital to the success of Artemis in the long run. Not only does NASA highlight the steady innovative process, but also general surface operations and more. Here it highlights important factors to consider including EVA availability and this process, depending on NASA's success in different departments. In addition to the process of sample collection and more. Here I will go more in depth into what NASA has planned, and what it will look like across future Artemis missions. As I mentioned prior, a big part of this process has to do with CLPS or Commercial Lunar Payload Services. Here 14 US companies are on contract and eligible to bid on science and technology payload deliveries to the moon. For example, Astrobotic and Intuitive Machines each have one task order award for deliveries in 2021. Astrobotic will carry 11 payloads to Lacus Mortis, a larger crater on the near side of the moon, and Intuitive Machines will carry 5 payloads to the Aristarchus Plateau, a volcanic terrain in Asinus Procellarum that is one of the moon's largest ore deposits. In addition, Viper and the Maston delivery will become the first surface explorers near the south pole of the moon, and will provide ground truth of the polar volatile deposits and the polar surface environment, furthering both scientific and exploration objectives. These early robotic investigations will increase our knowledge of the lunar environment and confirm the nature of the moon's vast resource potential, informing planning for future human and robotic expeditions, including Artemis missions beginning in 2024. All of the missions a part of CLPS play an extremely important role, and are a great example of NASA working with the commercial industry to get help. In this case, it provides NASA with more information and resources that they can apply to future missions, and the companies involved get a large amount of funding and unique missions. This encourages innovation through each Artemis mission as time goes on. Another vital process revolves around the order of missions and differences between Artemis 1, 2, 3, etc. NASA's SLS rocket, Orion crew vehicle, and supporting ground systems, will be the backbone for deep space transportation. The first integrated flight test, Artemis 1, will be an uncrewed flight to validate the system's performance in deep space, and Orion's thermal resilience to Earth return speeds. This is expected to happen very soon. Artemis 2 will be a crewed test flight to validate the life support systems, communications systems and scenarios, and manual flight controls in a rendezvous and proximity operations demonstration. Artemis 3 will be the first human mission to the moon in the 21st century. Astronauts aboard Orion for Artemis 3 will rendezvous with a Human Landing System (HLS) vehicle in lunar orbit to make their descent to the lunar South Pole. Here the choice of SpaceX to provide a lunar lander will come into play in a big way. Artemis 3 astronauts will spend up to 6.5 days on the surface, living inside the HLS crew cabin that they will then use to launch back to lunar orbit to rendezvous with Orion. In addition, it's well known that time is very valuable in space and especially on the moon. In order to make sure NASA takes advantage of every minute they spend on the lunar surface, they are planning to pre-position a lot of resources. Science at the moon will be enabled by crew access to the lunar surface. Pre-positioned assets are a potential consideration that could leverage CLPS delivery capabilities and relieve mass margins aboard the HLS. Pre-positioned assets could include geologic sampling tools, containers for sample return, instruments for geologic analyses, or experiments for crew deployment. Sample documentation equipment such as tags, barcodes, and cameras will also be necessary and can be pre-positioned, all of which will have a big impact on future missions to the moon. We now can take a closer look at the logistics and plan behind initial moonwalks and more. NASA highlights that the number of EVAs, or moonwalks, and their durations will depend on the down mass permitted on the HLS, and the allocation of resources for the spacesuits and portable life support systems. NASA has established a minimum requirement of 1 planned, and 1 contingency EVA for Artemis 3, but the goal is for the crew to do at least 4 moonwalks with reserves available for a 5th contingency EVA. As the mission draws near, and the landing site or region is defined, NASA will prioritize specific science activities for the surface expedition crew. Well, the specifics for the EVAs will be determined once the landing site is selected and a science plan is developed. We know that each EVA will begin with tool selection and preparation for investigations performed on that EVA. Having astronauts on the surface of the moon is necessary in order to make substantial progress. Here humans can work on science, sample collection, testing, building, and much more. Lastly, you have the very important sample acquisition and curation. The Artemis acquisition and sample curation plan development is yet another multi-directorate effort to address sampling strategies, collection and curation tools, containers, storage, and transport from the lunar surface back to Earth. Because the lunar surface infrastructure is expected to grow throughout the 2020s, the plan includes a phased approach that begins with minimal assets assumed to be available for Artemis 3 with gradually increasing capabilities based on additional assets throughout the decade. NASA may also have the opportunity to pre-position geological sampling tools and storage containers using CLPS landers. The goal of Artemis curation is to enable the sample science investigations needed to accomplish the Artemis science objectives and to preserve the Artemis returned samples for future science to the greatest extent possible. To enable a robust program of sample acquisition and curation and provide seamless scientific access to Apollo and Artemis samples, extensive Artemis sample curation planning has already been started by NASA. Conclusion. Not only landing humans back on the surface of the moon, but setting up a more permanent human presence is a very complex and difficult task. NASA has laid out in-depth plans and timelines for Artemis that each focus on a different goal or problem that needs to be solved. A big theme you will notice throughout Artemis has to do with working with the commercial industry. This is a unique opportunity that provides NASA with a lot of extra help from different companies around the country. We will have to wait and see how Artemis develops over time and the impact it has on the space industry. Thank you very much for watching.